Now in class 12th, I am taking the combination of electric cells. There are three combinations of electric cells. Now one is the series combination, second parallel combination, and third the mixed combination. And the combination of these cells is only to obtain the maximum current. This is the main purpose to combine or grouping of the cells. The purpose of combination of cells is to obtain maximum current. Maximum current in the electrical circuit. This is the purpose. So now let us say the first is series combination. Let here we are having the two cells. This is now external resistance. Its EMF is E1 and the resistance of internal resistance R1. This is now your E2, internal resistance R2. This is one cell. This is the another cell. Another cell. And let they give the current I in the external circuit. This is now external resistance R. So now here the total EMF, this E equal to E1 plus E2. Now total internal resistance R, this is equal to R1 plus R2. So now current, therefore current I is equal to E upon R plus R, or this I is equal to E1 plus E2 upon R plus R1 plus R2. This is now current. And now you can see that if the internal resistance of the cells is minimum or this is 0, then current will be maximum. For ideal cells, R1 equal to 0 and this R2 equal to 0. So this I is maximum. This is equal to E1 plus E2 upon capital R. So much. If suppose these are connected in the reverse order, let two cells are connected in रिवर्सली। तो इसमें क्या है ना, ये आपका सेल है। अब इसमें एक इस तरीके से this is now E1 and this is E2, and now this is now current I, this is now resistance R1 and this is now resistance R2. Now the cells are in reverse order. So in reverse order what we have? Here we have taken this E1 plus E2, here we will take the E1 minus E2. So current I equal to E1 minus E2 upon R plus R1 plus R2. R1 plus R2 ये क्यों है? If E1 greater than E2, और यही this I is equal to E2 minus E1 upon R plus this is now R1 plus R2, and this is if E1 less than E2. अगर इससे कम होता है तो whichever is more that we have take the difference. If E1 is more than E2, then E1 minus E2. If E2 is more than this E2 minus E1, the total resistance will remain the same. There will be no change. So this we have taken for the two cells. Now suppose the n cells, each of EMF E and internal resistance R are connected in parallel. Then what about the current? Let n cells, each of EMF E and internal resistance are connected in series. So what we have now, this is now, suppose this is now resistance and then this is now resistance and then this is now resistance, and let there are number of n cells are connected. This is not so much. This is now external resistance. Now its EMF is E, its EMF E, and this is E, this is now your R, and R. All are giving the current I in the circuit. This is now so much, and positive, negative, they all positives are on the same side. So now total EMF, this E equal to E plus E plus E plus up to N, then this will equal to NE. This is equal to E. Total internal resistance, now this R effective, this is equal to R plus R plus R plus, this is up to N. So this is equal to what? NR. Therefore current in the circuit, current I, this is equal to total EMF, this is now E upon R plus R effective. So this is, we can write to this. Then this I is equal to NE upon R plus NR. This is now current. So now you can see from here, if R is very greater than NR, then I is equal to NE upon R. So this is the maximum current. This is not maximum current. This so much. This is maximum. Maximum. Now if R is very less than NR, then I is equal to NE upon NR. NR will cancel. So we have this I equal to E upon R. This is the minimum current. Minimum current. So the cells must be used in series only when the external resistance is more than the internal resistance. The cells must be connected in series if external resistance is more than total internal रेजिस्टेंस। जब ये कंडीशन हो तभी सेल्स को सीरीज में लगाना चाहिए, अन्यथा इससे लगाने से कोई फायदा नहीं। Either you take the one cell or you take the n cell, then current will be like this one. If this condition is satisfied, and if this condition is satisfied, then all the cells will act and all cells will provide the current. That will be n times of the current provided by a single cell. So this is to be beneficial condition for series combination. Now here we take that suppose some of the cells are reversed. Now let P equal to number of cells reversed or wrongly connected. और wrongly connected. अगर ऐसे सेल्स हैं तो इसमें क्या करेंगे? Then how to find this EMF? Then effective EMF. into E. This is the EMF of N cell of the right cells which are have been connected in the right way, minus P. This is the EMF of cells which are wrongly connected or in the reverse way. Then this is to be so much. So this is equal to N minus 2P into E. This is now EMF. Then what about the current? Then current I equal to N minus 2P into E upon R plus NR. This will be so much. तो अगर मान लो कि N सेल्स में से P सेल्स ऐसे हैं जो कि गलत तरीके से लगाए गए हैं, तो उसमें हम करंट कैसे निकालेंगे? वो इसके लिए ये फॉर्मूला. दिस इज नॉट वेरी इंपॉर्टेंट फॉर्मूला because sometimes the question is asked in the competitive exam on the basis of this formula. So this is the series combination of the cells. Now second I take parallel combination. Now let us take the two cells. This is now suppose a cell. This is another cell. Both are providing the current in the. This is now suppose positive. This is now positive. This is E1, this is R1, E2, internal resistance R2, and this suppose provides the current I1, this provides the current I2. Then the current passes through this one, this is now your I, then this is now your R, and it goes here. This is now again I1, and this is now again I2. This I have taken the parallel combination of two cells of different EMF and different resistances. Then how to find? Now terminal voltage across these two cells will be the same. So what we have? This is now I. This is now voltage. That will be the same. Terminal voltage is the same. So what we have? Now first is I equal to I1 plus I2. Because this I and this I1 they will meet and this will make the current I that will pass through this resistance R. So this V is equal to IR and this is equal to I1 plus I2 into R. This is equal to V. Terminal voltage of this to be so much. And then now this we can have this V is equal to E1 minus I1 R1. I1 R1. This we know that V equal to E minus IR. This is the potential drop across this resistance R1, and V is equal to what? That we have this I1 plus I2 into R. This is equal to E1 minus I1 R1. Or if we more better, we can write this E1 minus I1. I1 we take common, then this will be your R plus R1. I1 to this from this side and minus I2R. This is equal to 0. This is now equation number 1. Now similarly for this second cell. Then similarly, this is now your E2 minus, this will be your I1 R plus R2 and minus I1R. This is equal to 0. This is now equation number 2. Now if you solve all these, solving equation 1 and 2 for I1 and I2, we get this I is equal to, this is your E1 R2 plus E2 R1 divided by R1 plus R2. This is not so much. Upon R plus R1 plus R2. This is equal to the current I. This is so much. So this is when the two cells, the positive terminals are on the same side. If one of the cells is reversed, one cell is reversed, then this I is equal to this is your E1 R2 minus E2 R1 upon R1 plus R2 divided by R plus R1 plus R2. This is not so much. And this we have taken when E1 is for E1 greater than E2. अगर हम इसमें E2 ज़्यादा होता तो यहाँ पर टर्म ये वाला टर्म पहले लेते E2 R1, then we have to apply to this one. So this is the current when the two cells of different EMF and different resistances are given. Then we have to find the current like this one. Now let's suppose there are n cells, each of EMF, EM internal resistance are connected in parallel. Then what will happen? The current. Now let n cells, each of EMF E and internal resistance R in parallel. Then what will happen? Now here we have this, the cell, so much, and just there are n cells, and all these cells are providing the current. Then this is now positive, this positive, this positive, this positive. This is now ENF, each of ENF E, and internal resistance, suppose this is now R, and they are providing the current here in the external resistance. This is not so. If this is like this one, then the total EMF will be how much? Total EMF. E is equal to E, and the total internal resistance this R effective, this will be your R upon N. So total current will be how much? Therefore current I is equal to E upon R plus R upon N. This is not so much. Now from here we can have that if R is very greater than R upon N, then what will happen? Then I is equal to E upon R. This is the minimum value. This is minimum. And if R is very less than R upon N, then this R will be neglected. Then I equal to N E upon R. This is not so much. This is the maximum current. Maximum level. So the cells must be connected in parallel when the external resistance is very less in comparison to the internal resistance of the cells. For maximum current, the cells must be connected in parallel if the external resistance is very small in comparison to total internal resistance. Total internal resistance. This condition must be satisfied. Only then useful, otherwise this is not useful. So you can find the power in the load. Power in load R, this P is equal to I maximum square into R, and I maximum, you know this not so much, so this is your NE upon R whole square into R, so this is N square E square upon R square into capital R. This is not your P. This P will be maximum. P maximum. Because current is maximum, so this P is also maximum. So this is the power in the load of this, or load means the external resistance R. So this is about the parallel combination of the cells. Now I take the mixed combination of the cells. Now third, mixed combination. Then here we have that let n equal to number of cells in each row, m equal to number of rows. So total number of cells is how much? So total number of cells equal to capital N. It means that this capital N equal to M into N. So now what we have? This is now like this. I am connecting cells in the mixed combination, and this continues like this. Then we are having this. Now then all these this is external resistance R. Here is the current I. That is the passing through this one. Is each of EMF E. This is now R and R. E. This is now R. Here this is E. This is now R and R. All these are providing the currents. So what will happen? The total internal resistance is EMF. This E is equal to NE, and total internal resistance. Now this R effective. This is equal to how much? We are having this N R upon N. How to find R plus R plus R up to N? This is NR. This is also NR. This is also equal to NR. Then all in parallel. 1 upon NR, 1 upon plus 1 upon NR plus 1 upon NR up to M. So this is now M upon NR. So this is now NR upon M. This is the effective resistance, internal resistance. So current I is equal to total EMF E upon R plus R effective. So this I is equal to NE upon R plus, we are having this R effective is NR upon M. This is so much. Now then we can have a little calculation about this internal about the maximum current. Now this can be written as this I equal to NE upon. Now we can write to this one in what way? This is now square root of R minus NR upon M whole square plus 4 N R into R upon M. We can write to this one in this way. If you simplify to this one, then this term will come out here. So for maximum current, for I equal to I maximum, what should be there? This R minus NR upon M, this must be equal to 0, or this R equal to NR upon M. Therefore, I maximum, this is equal to NE upon square root of, what will happen? Now this term is 0, this we have made 0, this is now so much 4 N R into, now in place of R we will write down this N R upon M. N R just a moment. N R, then this one upon N R, so M upon N R. So N R upon M. This is now R effective. This is your NE. This is now whole square. N R upon M. This is now your M. This is now term M. Now this is now M. We have put the value of R here. That is N R upon M. So this will be your N E upon 2 N R upon M. Right? This will be whole square, this n and n will cancel. Then I maximum is how much? I maximum. This is equal to NE upon 2R. This is now I maximum. When I is maximum, then the power maximum is how much? Maximum power. In load. So this P maximum is equal to I square maximum into R. This is so much. So now we have P maximum. This is equal to ME upon 2R whole square into capital R. So this is equal to M square E square upon 4 R square into capital R. This is now your P maximum. And if suppose you write down this NR equal to MR here, NR equal to MR, then MM will cancel. Even the will have the same power to be here. So now you can see that the mixed combination, the maximum power maximum current can be obtained when the external resistance is equivalent to the total internal resistance. And this is the maximum power. Thus, if external resistance R is equal to total internal resistance of cells, then the current is current and the power are maximum. तो ये क्या है कि we are getting the I maximum P maximum under same conditions. So this combination of the cells is preferred because of it. Since I maximum and P maximum are under same conditions, same condition. What is same condition? This capital R equal to NR upon N. Under same condition. So mixed combination of cells is preferred to series and parallel combination. Combination of cells. तो आप इसमें देख रहे हैं क्योंकि एक ही कंडीशन के अंदर आई भी मैक्सिमम हो रहा है और पी भी मैक्सिमम हो रहा है, इसलिए एक जो ग्रुपिंग होता है ये ज्यादा बेनिफिशियल होता है इन कंपैरिजन टू द सीरीज कॉम्बिनेशन और द पैरेलल कॉम्बिनेशन. So this is what we have the three types of the combination of the cells, and since we have to obtain the maximum current and the maximum power that you can obtain from this formula. Also you can see that this maximum current does not depend upon the number of cells used in the that since the n is not coming in this one. So the maximum current is equal to so much and maximum power is equal to so much. So thank you very much.